Welcome back, children. So let us start the calculation. Supposing here is a source of sound and here is a wall. This is the solid obstacle and this is the source of sound. The distance between the source of sound and the solid obstacle is supposing d. So as sound is produced in this way, it moves in the forward direction. After it hits the solid obstacle, it gets reflected back. So let's start. Let a source of sound is kept at a distance d from a solid obstacle. Let the speed of sound in air is equal to V is equal to say 340 meter per second. The persistence of hearing for man is equal to T is equal to 1/10 of a second. So total distance travelled by sound is equal to, now you are hearing at the same place. Supposing you are hearing from here, this is your ear, right? Okay, you are hearing the sound. So total distance travelled by sound is, while going from the source to the solid obstacle is d. Again, while returning from the source to the observer, the observer here is d. So that is d plus d, that is equal to 2d. Now we know distance is equal to speed into time. So here distance is 2d, that is equal to speed is 340 meter per second into time is 1/10 of a second. So if I cancel second and this 0 and this 0, you get d is equal to 34 meter by 2, that is equal to 17 meter. So in this way we can calculate. Here I have taken the speed of sound as 340, so it is coming 17 meter. If you take the speed of sound as 330, automatically this will become 33 by 2, that is 16.5 meter. So in general we say 17 meter, 16.5 meter, 17 meter, this varies. So for that reason, in a small room, even if you produce a very big sound, you cannot hear the echo. Why? Because the walls are so close that the original sound, the duration between the original sound and the reflected sound that enters your ear is much less than 0.1 second. Hence you are unable to hear echo. But if you enter a large room where sufficient distance is there between the wall and the source of sound, and you clap, you will hear a second sound of clap. Same thing happens when you go to a hilly area, a mountainous region. So after moving to the top of a hill or mountain, if you clap your hand, then you will hear echo of that clapping. So, understood, children? So in this way, we get the minimum distance required for echo to be produced is 17 meter when speed of sound is 340 meter per second, or it can be 16.5 meter in place of 17 meter, 16.5 meter if the speed of sound is taken as 330 meter per second. But it will generally varies between 16.5 meter and 17 meter. So just for making your calculation easy, I have taken at 340 meter per second. Now children, you will be surprised to know that though we human beings cannot hear infrasonic sound wave or ultrasonic sound wave, some animals are there which actually utilizes this echo system for getting their prey, for obtaining their prey. For example, bats. Now you must have seen that when bats enter a room, it never collides with the wall, neither it collides with the blades of a moving fan. You must have observed sometimes it has happened. Now that is because whenever a bat flies, continuously it produces sound which is ultrasonic sound wave, and its frequency is not less than 1 lakh hertz. 1 lakh. And then its spread wings acts as radar, which helps in absorbing the reflected sound from a solid obstacle. The solid obstacle can be a wall, it can be anything, it can be a tree, it can be anything, it can be an insect as well. And it can easily understand how far the obstacle is. If it is an insect, the bat is able to understand how far from it the insect is actually located. And then it moves and catches its prey. Similarly, other animals like dolphins, whales, they communicate with each other with the help of ultrasonic sound, by producing ultrasonic sound waves. Another very common animal which can hear ultrasonic sound wave is dog. Dog has the capacity to hear ultrasonic sound wave up to 50,000 hertz. Remember. So that is why dog trainers use a special type of whistle called as Galton whistle, which can produce ultrasonic sound waves. And with the help of this particular whistle, they are able to train their dogs. Remember, the name of the whistle is Galton whistle. This Galton whistle is capable of producing ultrasonic sound wave, with the help of which dog trainers are able to train their dogs. So in this way, we can calculate, as I said, this ultrasonic, the minimum distance required for echo. Okay children, we will resume our class for the next topic in our next class. Thank you.